In this video, we're going to go over the vector class in C++, and we're also going to talk about big O of all of the major member functions. So first, you're going to need to become very familiar with the C++ documentation so that you can understand how to use the container. So here is the link to the class, or to the documentation. So it's very similar to our vector that we've been using in this class. A vector is just a sequence container, which you now know what that means because we defined it last time, that can represent a dynamic array. The memory that's used for a vector is contiguous, which means it's next to each other, and it can be accessed using pointers just like arrays can. But unlike arrays, it's dynamic. So that is the very first part of the documentation for a vector. What I'm going to do is I'm going to go through and talk about the constructor for each container, and then I'm going to talk a little bit about how it's implemented because it really helps understand the big O. Then I'm going to go through and with an example I'm going to show you the different behaviors of the container and talk about the big O of each of those things. So the constructors first. In C++, the containers generally have lots of different constructors, so this is just the default one that has no parameters passed in. And as we talked about, the constructor is what allocates memory under the hood, and it instantiates the vector, which means it takes that class, which is like that blueprint or that recipe, and it makes an instance of it, which we call an object. So that's what the constructor looks for a vector, exactly like the R vector that you've been using. We already talked about this with R vector, and it's the same with the vector implementation. It's something that grows in capacity. So under the hood of the vector implementation, there is an array, and the array is allocated at the call of the constructor, and it has to be set to some capacity. And a lot of you really got to see this in the R vector implementation with your project when you looked at those R vector stats. Then as you push things back into the vector, it starts filling this array and it updates the size accordingly. So the implementation of the vector under the hood is that it is an array. And you can actually see that in the documentation of the vector, which I don't think I included here. And there's a couple different implementation options for the vector class in C++. But they all have very similar behavior in the things that we're going to be talking about. So you can assume that the implementation of the vector is an array. So we're going to do this example where I'm going to write a bunch of functions using vectors, and then I'm going to continue this example for every other container as well, so you can kind of see like the same problem being solved with different containers. You can't solve it in the same way with different containers, or maybe you wouldn't want to, but it's going to be the same problem in all of these. So we're going to be using this file here. The file just stores UINs and net IDs for a list of students. I also am linking the code that I'm going to be showing you here. It'll also be posted on Blackboard so that you can follow along if you'd like. Some of it I'm going to show through demo, and some of it I'm going to show through just putting the code up on the slides, but you'll have reference to the code, through both the slides, the code itself, and just watching in the demo. So I put it all in one file so you could see it all together. So this is the part of the code that we're going to be running right now. So I have a function that fills the vectors with the UINs and net IDs that I just showed. I have another function that can print a vector, and then I have another function that can search. So let me just show you what it looks like when I run it, and then we'll go through each of the functions. So it just ran and it filled the vector, and then here it is printing out. It filled both vectors, and then here it is printing out both vectors. Then what I can do is I can do this. I'm in the search right now. I can grab one of the UINs and I can search it, and it will tell me which net ID it's associated with. I just went ahead and did the last one because it's easy to see, what it matches, and then I'll do the first one. So you can see that those match up by index. And then if I look up one that doesn't exist, it can't find it. So that is the code that we're working with. So now I'm going to go through and show you on the slides what each of those functions is and how it looks like when you use the vector class, which again, for this one, it's really similar to our vector, so probably not too bad to understand. So the first kind of operation that I want to go through with every container is the insert operation. So that happens in the fill vectors, and basically pushback is the insert operation for vector, and we're going to just talk about what the big O of insert is. So it depends, right, on where you insert. So if you insert into the back of the vector, which is what pushback does, then the big O is basically 1. So again, assuming that there's capacity, and there most of the time is capacity, and then every once in a while there isn't capacity, and it needs to grow. Over time, it's averaged out to approximately constant to insert to the back. But as you know, you don't always insert stuff into a vector at the back. So if you insert somewhere else, like for example the front, that has O of n complexity, because if you move something to the front of the vector, everything behind it has to be shifted. And so if you count up all those operations, there's the same number of operations as there are things in the vector, right? So that's insert for vector. Let's look at accessing. So accessing into a vector is going through and indexing into it using the square bracket operation or the @ operation, which you've all done many times, or just doing a for each loop, right? So if you want to access an element in a vector, one of the advantages of this dynamic array or this vector class is that it has constant access. So if you know that you want to access the third element, or you want to access a specific element, then it's just one operation. You just grab it. And you know that from our big O analysis, right? Indexing into a vector and accessing something is O1. So these are the two pros for vectors. Inserting at the back is great, and the direct access, the direct random access to elements in the vector class, those are the two advantages of a vector. Now let's look at search. So I showed you how search worked when I ran the code. This is what the code looks like. It just has this user prompt, and it continues to prompt for the UIN until the user puts in 0, which means they're done looking up. So all the search code is actually here, and the search code is very similar to the search code that you wrote for previous projects, which is it just loops through and it does a comparison for whatever it's looking for. So it's looking for the UIN that the user put in. So it's comparing the UIN to the UINs in the vector. And then once it finds it, it saves the index and it breaks out of the loop. Then if it doesn't find anything, then the initial value of -1 that it's set here won't have changed, and so it didn't find it. If it did find it, then you can go ahead and match up the index from the UIN vector to the net ID vector and print it out. So that's search. So what's the big O of search? Well, worst case is that the thing you're looking up is at the end of the vector and you have to work through the entire vector, and then that search is O of n. And many times If you don't find it, you also have to go through the whole thing and search. So search in vectors is expensive. It's ON for linear search. So if you have to walk through the whole vector, if you don't know anything about how the elements are stored in the vector, that's an ON operation. So insert, access, pretty good for vectors. You can make it work for vectors, but search, it's expensive, O(n). We didn't talk about remove. I'm going to show the remove big O for every container, but it's not really that much more confusing than insert, right? It's just like the opposite. So again, if you remove something from the back, it's easy. If you remove something from the front, it's an ON removal, right? Because you have to shift everything. Vectors, some important notes. You have both for each loops and iterative loops, and you actually need both of them. So as you could see, when I printed something out in the for each loop, I could just, or printed something out in the vector, I could just use a for each loop. But when I was doing a search, I needed to know what index it was at, so I needed the iterative loop. And so there are cases where you're going to need both of those. There is the square bracket versus the at. They are different. In the C++ implementation, the square bracket function does not do bound checking, and the at function does. So you'd have to be careful if you were going to use that, and check yourself if you want to use the square brackets. Size. We're always using size, and if you're curious, what is the cost of size? Go into the rvector implementation and look at what that function is. All it does is it returns a variable. It returns a private member variable in the class. So sizes kept track inside of the class, so it carries with it its size. So it doesn't actually have to go through and count the elements in the vector or in the container when you call size. It already has knows what the size is from what member variables have been called. So it's actually not expensive at all. It's a constant call. It's a constant, it's a big O of 1. And then make sure to check out all the constructors. There's lots of different ways to actually create an instance of an object in all of the standard libraries with C++, and so there might be one that is more useful than the default one. So that is it with C++ vector and its big O.